project we'll be looking at today. So today we'll be looking at this. Okay, stays and okay. So this is data set we are looking at. It's the healthcare data set and it consists is it this? Oh sorry about that. Not this one. Okay, this is it. So called our data set and it consists of patient's ID, the appointment ID, the gender, due dates, the appointment day, date, the age, the neighborhood this patient resides in, if this patient is medical condition of this patient, hypertension, diabetes, alcoholism, and not. We also have SMS receive, and this row talks about to receive a message to inform the patient that okay, you are to particular day or not, and if this patient actually showed up or not. That's for the no problem. Okay, so we're going to be analyzing this data set and we'll be looking at some key get out some key insight from this data set. If you look at this data set, you see that we have to do so that there's no way you can go ahead analyzing cleaning. Data cleaning is one of the most essential parts when it comes to analyzing any data, either being healthcare data, financial any data at all. You just know that you have to clean it first. Okay, so I'll go ahead and just go to Jupyter notebook and let's just questions, just drop it in the chat, but from time to time I'll try my um answer any of your questions. So this is my Jupyter notebook, and I will just walk you through the process of this. I have Anaconda on my system. Okay, so I have Anaconda on my system, and I make use of Anaconda because as a it has a whole lot of notebook or IDEs I can use in analyzing my data. So it comes in example you see here. I have a Jupyter notebook. I have on this Anaconda on this. Okay, you could see Jupyter Lab, Orange, and so forth. But for me, I make use of Jupyter Notebook. Okay, so you can just go ahead and launch and it comes up for you. Okay, so I already have this launched on my system, so I don't want to go through the stress of doing that once more. But once you click on that launch button, what interface comes up, it just props up for you. Okay, so this is it. This interface props up for you, and if contains all my project folders, my notebooks. It's just like it gives you a view of all folders or notebooks that are present within your computer system. So you can go ahead and that you can just, in case you want to have a folder where you skip up all your data projects you want to be working on, you can go ahead and create that folder. And within that folder, you can now go ahead and create your notebooks. Okay. So for example, this this is a folder. This is a folder which I created. Okay. And this folder holds my project. So if I take a look at let me go up. Okay, we have the DSA project as data science or data analysis project. Let me open this. You see, I have a whole lot of notebooks that are here, consisting of projects that I have worked on, one way or the other. So I can go ahead and click on this new, and I'll be creating a new notebook. Just click on Python 3. You'll create a new notebook, and you can now go ahead and work on that. So if I click on this, you see a new notebook is going to pop up, and I can go ahead and carry my data analysis on that notebook. So that's just a brief run through on how you can, use Anaconda for analyzing your data. So I will just go ahead and close this because I already have a notebook which I've set up, and it contains and the steps we'll be using and some objectives or insights I would like us, some questions we would want to answer. So as a data analyst, first of all, when you've gotten your data set, or before you even getting a data set, let's say in a real life scenario, definitely you would discuss with your stakeholders, and they will give you, or you have a meeting where you discuss with your stakeholders, and you have like questions or findings or insights you would want to answer, or they would want you to get these findings or insights from the data, right? So this is what we are doing. We are assuming that this is our data set we have gotten from our hospital setting, our healthcare setting, and they want us to analyze or answer these questions. They want to get findings on, okay, some patients are missing their appointments. Is it because they were not reminded? Is it that patients that got messages are more likely not to miss their appointments, or they are more likely to miss their appointment? Is it because we have a scheduled date and an appointment date? Is it that patients who scheduled earlier are more likely to miss appointment or not? Or is it that a patient who has a certain diagnosis is likely to miss appointment? Is it that a patient who is from a certain neighborhood? Are you getting my point? So these are a lot of questions that you would want to answer, or findings that healthcare setting would want to get for them to give a more better care to their patients. The whole essence of analyzing healthcare data is because they want to improve care that is being rendered to a patient. So if I have this data set, how can I get findings that would improve the care that is going to be rendered to my patient? Okay, so that's what we are trying to do. So, the first thing we'll be looking at is we have the steps here. We'll be going through each of these steps and we'll be answering our questions. So, our step one is import our needed libraries. So, what are those libraries we'll be needing? So, imagine we just opened our notebook. The first thing you are going to do is to import your libraries. Those things, what are those tools you are needing? So, we need want to import libraries like pandas as PD, numpy as import numpy as np. Want to import matplotlib dot pyplot as plt. We want to import cbond as sns. Okay, so this first these and these are used for analyzing healthcare data in pandas, or analyzing data in pandas, right? Why these two libraries are going to mostly be used for visualization, data visualization, matplotlib.pyplot and cbond. Okay, I think I made it. Okay, and cbond. These two libraries are going to be used for visualization. Okay, so let's just go ahead and run this and ensure that these libraries have been imported into has been imported. Okay. Okay, so now the next thing we want to do, now that we've imported our library, to do that, pandas. So that's why we need to import our library first of all, because you've been needing this pandas now to read in your set. So be calling a pd.read underscore csv. And to do this, what we need to do is an easy way I always used to read in my file into my Jupyter notebook is, okay, I just go to my file, and the name of the file which we're trying to read is this file, right? Which is data. So I can go ahead and click on this, and go to properties. I'll be getting the properties, and you will see this is the name of the file. This is the location where it is located. It's being saved on my system. And this is the file type. So we're going to be needing these three important properties. So the first thing we want to get is the location of this file on my system. So I will just go ahead and copy this, go back to this, paste this here. This is the location, put a backward slash. The next thing we need, sorry about the next thing we need is going to be the name. Okay, so this is the name of my file. I'll copy this as well and paste here. And now we're going to be adding our file extension. So this is a CSV file. So I can just go ahead and copy this as well. Say this, okay. And I can add this, okay. So remember is .csv, and I'll be adding an arrow here to read this in. And next thing, I want to save this, give this a name, and I'll be calling this, let me just call this data. Let me just call this uh hospital data for short, and we can now go ahead and read this in. No, so now just the first 5 rows of this data, because I don't know how many rows or columns, how large this data set is. Okay, so I just want to see the first 5 rows so that it doesn't become too clumsy. So let me go ahead and read that in. We'll wait for a few seconds, and oh, we are getting a fine not found, and it says CSV. Okay. Oh, this is project, sorry. So let me go ahead and read that once more. Okay, so we've gotten our data set. So we have our patient ID, the appointment ID, the gender, the schedule day, the appointment day, the age, neighborhood, NHS, that's if this patient is under the NHS scheme or not. We have hypertension column, diabetes, and so forth. So we have a whole lot of columns and rows. I just want to know, I just want to get a brief understanding on what my data set is about. So imagine that these rows were more than this, and we have rows up to like 50 to 150 rows. It will be difficult for me scrolling left and right, trying to get how many rows we have in this data set. So a very easy way you can go ahead and do this is use the dot info method. So let's say hsp underscore data dot info. Okay, and if I go ahead and run this, we'll be getting a brief info on my data set. Okay, uh hope you can hear me, and you can see my screen as well. Okay, so I'll be getting a brief info on this data set, and here we see we have the patient ID, the appointment ID, gender, schedule day, appointment day, age, neighborhood, and so forth. So you can see all our columns we have in this data set, and it also tells us the amount of rows. So range index tells us the amount of rows. So we can see we have 110,527 rows of data, and we have 13 or 14 columns of data. Okay, and it contains, we have floats, integers, and objects that are strings in this data set. It also shows us each column, the number of rows we have in those columns, and the data type in those columns. So for example, our patient ID is a float, and our appointment ID is an integer, gender is an string, and so forth. So you can see from just this brief info, we are already seeing some things we have to correct about this data set. For example, patient ID, which is a float, is not supposed to be a float. It's supposed to, although we know it's numbers, right? But it's supposed to be an object. It's supposed to be a string value, because these IDs are technically should I say, these IDs are technically numbers that are used to represent a patient, and we don't want numerical operations to be carried out on them. Okay, so we want those to be strings, our appointment ID to be objects, which is strings, and we also have some corrections to do. For example, our schedule day and our appointment day, which is a date, is supposed to be a date data type, not an object data type. So you see, we've already started seeing some things we have to correct about this data set. So that is one of the importance of, first of all, getting a view of what your data set is about. Another thing we do is I can decide to call the dot shape attribute on this data set to see how many rows and how many columns we have in this data set. So if I go ahead and run this, it confirms the information which we got earlier, which says we have 110,527 rows and 14 columns of data. Okay, so now now that we've gotten a brief insight of what our data set is about, we can now go about to our step two, which is our step three, which is step four. We've read in our data set, which is step two. We've gone through our data set, which is step three. Our step four, which is data cleaning. So let's go ahead and carry out some data cleaning on this data set. And the first thing we want to clean is our column names. So for example, if you look at this data set, we have this row or this column of data titled hypertension, which is spelled wrongly. It's supposed to be HY, but we are having an HI there. So we have to correct that spelling. Then we can also do some renaming of our column. So for example, our no show, which represents if a patient came to the hospital on the appointment day or not, would like to change this column to a more befitting name. And for handicap, you can say we have handicap instead of handicap. So we can also change that. Okay, so that's one of the first thing we'll be cleaning about this data set. So let's go ahead and do that. So we are carrying out data cleaning, and I want this change this to markdown. I will just go ahead and run that. Okay, so we want to rename columns in the data set. Okay, so that's the first data cleaning we would be doing. So to rename columns in your data set, we have to make use of the dot rename. um we have to make use of the dot rename method. So let's say call the name of our data set, which is data dot rename, and pass in our brackets. And now, okay, we'll pass we'll pass in a dictionary, and this dictionary is going to be taking two things. The key is going to be the previous name. For example, here we have hypertension, so this is going to be our key. And the value is going to be the new name we are changing it to. So we are changing it to hypertension, but a correct spelling, right? So another column we are cleaning is the handicap column, right? So we'll be cleaning this also. So for dictionaries, when you are using dictionaries, it can take a lot of keys and values. So we'll be just adding your comma, the next column you want to claim, and the name we are cleaning that as. So that's for handicap. Then also we'll be cleaning our no show. So let's change that to missed appointment. Okay. So for the no show, you will see we have no and yes. So for no, it means the patient did not miss the appointment, and yes means the patient did not show up, meaning the patient missed the appointment. So this no show is the name is a bit technical, is a bit confusing. So let's change this to a missed appointment so that if we are saying missed appointment, no, it's okay. This patient did not miss appointment. Yes, the patient missed appointment. Okay, so let's go ahead and do that. So no show. I'll copy this, paste this here, and this will be missed appointment. Okay, so I can go ahead and run this. And if I run this, the changes will be seen in the data set. But to keep these changes in place, I'll be adding the dot in place. And I can now go ahead and run this. Okay, we saved our data set as hospital data. Let me just go ahead and copy this. Okay. So if we go ahead and look at this data set once more, and look at the dot first 5 rows on this data set, and let's see if our changes were done. Okay, so now you can see for hypertension it's not correctly spelled, handicap is correctly spelled. We've also changed the name of our no show to missed appointment. Okay, so I think we've done our first data cleaning step. The next thing I want to clean about this data is to correct column data types. um Earlier I said patient ID and appointment ID, they are supposed to be string data type, while the schedule day and appointment day are supposed to be date time object. So let's correct the first two, patient ID and appointment ID. So to change our data type, we can say the name of our data frame, which is HSP data, and we want to pass in list containing those two columns we want to change the data type, which is patient ID and the appointment ID. Okay, so let me go ahead and do this. Mm, So we first of all, I just want to check the type of this data set. Let's run this. The type. Okay, I hope this is correct. Okay, let's take it in. Um. Okay. Okay, we can just go ahead and add heads to this. Okay. So you can say we have our patient ID as floats as this, okay? Then now the next thing we want to do is to carry out a conversion. So let's use the dot as type and run this. And now let's go ahead and check this once more. Want to keep our changes in place. So let me just go ahead and paste this here and use the dot d types once more. Okay, so now you see we have our both our columns as objects and objects, right? So we've been able to carry out those changes. So I want to do is change the data type of the date columns. Okay, so how can I go ahead to do that? To do that is easy as well. You can make use of the PD to date time. Okay, PD to date time. So let's say the columns which we want to change our scheduled day and the appointment day. So this is it. Yeah. Okay. Sorry. I want to change this. Want to convert this to a date type object, right? So before I go ahead to do that, I'll be using the dt.date dot has type. Let's take this. Okay, I just want to make this okay as type, and we'll be using the date time 64s. Date time 64. Yeah. So let's go ahead and run this and see if we'll get any error. We're getting an error, and let's see where our error is coming from. Say to assemble mappings gradually, year specified month year is missing. Okay. Okay. Let me go ahead and mm, and let's see if we're going to get our error. Okay. So no error, and if I go ahead and copy this, and let's check the type of this, the D type, run. You can see now we are having a date time object. So same thing we did, we can just go ahead and copy this and duplicate for our appointments. This is the day. Okay. So if I run this and the type, I think we'll get an error. I did not add s to this. Let's see what comes up anyway. Okay. So let's go ahead and run this once more. Comma is missing, and let's run this. Okay, so you can see that these are both date time objects right now. So one reason why we convert our date to date time object is because we want to be able to, work with this as a date object. So you will see one of the reason why I am doing this is, for example, let's say we have our schedule day, which is the day the appointment was made, and we have the appointment day, which is the day the patient is supposed to come to the hospital. If we want to see the difference between the dates this patient scheduled the appointment and the day the patient came to the hospital or is supposed to come to the hospital, then we would have to convert this to a we would have to get the day, okay, from this dates, scheduled date and appointment day. And for a date time column. So let's say, okay, we want to know, look at this column right now. We could see that for our first patient, the day we have 2016th of 20, okay, we have 29th of April 2016. We can decide to say this day, is it a Monday, is it Sunday, is it Tuesday, Wednesday? You want to know which particular day. To be able to get that, we'll be using the day of week, or we'll be using the day name of our Python library to be able to get that. And for you to be able to use that, you have to use it on a column that is already a date time column. Okay, so I don't know if you understand what I'm trying to say. So let's get the day name for this date. Okay, so we're looking at our schedule day, but we want to call this our schedule day uh day name, and we'll be using same process. So we'll be saying pd dot to date time. We'll be calling the name of our data frame, which is hsp data. And also, okay, we're looking at the schedule day. And also now the next one to do is to add our dt dot day name, day underscore name. And with this, we're able to get the day that uh appointment was being scheduled. So if I run this, you see we have Friday. So it tells us the particular day of the week that appointment was made. So we want to do the same thing for our appointment day. So let's know that, okay, the particular day of the week the appointment was made for. Okay, so I just want to go ahead, copy and paste. So shorten our time we'll be spending on this, and we are looking at the appointment day column. This is the column we want to work with, right? So we we want this to be appointment day, and let's go ahead and run this. So you see it shows us the appointment day. So for example, you can see for this person scheduled, the schedule was a Wednesday, and he made the day he wanted to come to the hospital was on a Tuesday. Okay, so on a Wednesday, he's scheduled for the next day, Tuesday, as is our appointment day. So that's one of the reasons why I had to convert those two columns to a date time object. So the next thing I want to do, we've done with cleaning that data, we've corrected data types. The next thing on our data cleaning is to create categories. So I want to create categories with our age column. So let's go ahead and do that. So you see for our age, we have different when we are analyzing. So the first thing I always love to do when I'm creating category is I want to see what that column is about. I don't just want to go ahead and start, but I want to see what are the values that are contained in that column. So if I go ahead and run this, you see we have 62, and these are the various values in this column. You will see we have -1. I would assume that this person with this age is a baby and it's not up to 1 year of age. So we'll be categorizing this as 0. Okay. So you could see we have 0, we have 1, we have 2, and so forth. So these are the unique age in this column. Another thing I would want to do is to get the sum total of the unique ages. So I'll be using the n unique. So I'll just go ahead and add n in front of this, and I'll run this 4 unique ages in this data set. So now what I want to do now is to use the categories for this data set. And to do that, so to do that, for me to be able to use the pd dot codes, I would have to create bins and labels. But before I go ahead to do that, you see we first of all we identify -1. Okay, so I want to change or anywhere we have -1 as an age on this data set will be 0. Okay, so I will be using the dot replace method to do this. So let me just go ahead and copy this to make this faster dot replace. Replace a method, you just have to pass in a key, a dictionary, and you want to replace, in this situation, want to replace -1 and want to replace that with 0. Okay, so and okay, so if I paste this here and look at the unique data frame once more, stay saying this. Oh, sorry. Okay, let's go ahead and run this. Okay, so now you see that this minus and data set because it has been replaced with 0. Okay, so that's how you can go ahead and change or replace any value in your data set. So the next thing I'll be doing now is to go ahead and create those categories, those bins and labels. So for the bins, I'll be using 0 since our age is starting from 0. So 70 years of age, and from 85 to 64 years of age, and from 65 to 115 years of age. Why for the labels? So for 70 years of age will be classified as, let me say, child. Why from 18 to 40? Why going to be converting from 65 to 115 is going to be categorized as senior. We've created our bins, we've created our labels. Now we want to go ahead and categorize this. Just use the pd.cut, the name of our data set, which is HSP data. The column you want to call is H column. Now pass in your bin as bins. Okay. Our label as labels. And we want to add this parameter that says include lowest. So this just ensures that if we have any extreme low value like zeros, is ensuring that it's being included. So now we are creating a new column, and what we want to save this column as, we want to save this as our H category column. So let's say HSP data, and let's call this our H category. Okay, so H cats for short. So let me go ahead and copy this, paste this here, and I want to be seeing two columns. So not just the H category and the H category column as well. So you could see now our 62 years of age is middle age, 56 years is child, and so forth. So you can see we've created an additional column that has categorized the various ages into categories. Now, the next data cleaning, you've seen that we are spending a lot of time on just cleaning sets. Okay, so the next cleaning we are going to be doing is to drop redundant column. In it, we've categorized our age already. Okay, so you can use the dot drop. I'll make use of it. So I'll. And the next thing I want to do is to check for missing values. Okay, so uh, to check for missing values, you call out and let's add the dot sum. So would say us if we have is any missing value in this column. So you can see it turns up as 0. So we have no missing values in each of this column. In situations where you have missing values, there are different ways you can handle missing values in your data set. So one handle missing values is you can drop those missing data. But if you are working with healthcare data, careful when it comes to dropping missing data from your data set, because sometimes those missing data might not really be missing data. So you have to go back, do more, ask more questions. Why are these data missing? Are there any way you can get those data sets and feed those data sets? So this brings me to the second method, handle missing data, which is filling those data sets that are missing. And you can fill those data sets by using the fill any method, where you can use the mean, the median, or you know using the mean or the median to replace those data sets that are missing. But I would advise, before you go ahead and do that, ensure you've gone back, you've regarding those data sets that are missing, especially when you're working with healthcare data, affects your analysis of findings you'll be getting from your data set. Then in situations where you have a missing and you want to drop those data sets, of dropping about 30 to 40%. If you have about 30, you just have to delete columns if you have more than 30 to 40% of missing values. So you just have to you go ahead and drop those columns. There are other different methods you can go about with missing in your data set. The last data cleaning in here, missing inconsistency. So let's go ahead and do that. So let's check our data set if we have any inconsistent data, fixing inconsistencies. Remember, you can always drop your questions in the comment section. I'll be taking time to, go ahead and view them. Okay. If you have any question, drop them in the comment section. Clearly, let me know. Okay. Consistencies. The first, before you're able to fix inconsistency, then you have to first of all know if you have inconsistent data in your data set, right? So I'll be writing a short piece of code for me to be able to find out if I do. So first I want to loop through 3 columns and get the values in that columns. So for example, what this is all about, if you call the dot data dot columns, it's going to give you return all the columns you have. Oh, I always keep on using data instead of hsp underscore data, hsp underscore data. Okay. So if I go ahead and run this once more, you see it gives us all the columns in this data frame. So that's what we want to do. We want to loop through all the columns in this data set and we want to get their values. So we're saying for X in these different column names, we want to print at their values. Want to print hsp underscore data fix in X, and we want to get the unique values. Okay. So you see it's going to, loop through. So the first column here is going to be our patient ID. Then we have the appointment ID, you have gender. So in this case, you can see our gender. We have female and we have M as male. So we'll go ahead and correct this. Let's see if we have any consistent value. So when I talk about inconsistencies, there are situations where we can have female, and let's say for example, this same column will be having values like female for female, then probably female, which is also representing female. Then maybe we have something like female, we have F. So these are inconsistent values. If you don't correct them and say, okay, all females are going to be using one particular spelling, you are going to be having a wrong insight because you do not make corrections to these inconsistencies. That's why I always say check for inconsistencies in your data set and ensure you correct those inconsistencies. Okay. So we have no, yes. Okay. So I think that's just the only correction we'll be making in this data set, which is the M. And it's easy. We can easily do that by using the replace method, which I have shown you earlier. So let's say HSP data, and we are looking at our gender column. So we want to go ahead, copy this, paste this here, and we want to replace um M, which is male, and we want to be changing this to male. Okay. So now I'll copy this, and we'll be using the dots unique and see if our changes were affected. Hopefully it was. So you could see we have female and male in place of the female and M, which we had earlier on. So I can go ahead and remove this. So we've made that correction and we've cleaned our data. So you see that we've spent most of our time in just data cleaning. So when it comes to data analysis, data cleaning takes majority of the time. When you are analyzing data, you have to ensure that you've done correct data cleaning and your data set is now ready for analysis. Okay. So now after cleaning your data, the next step we have here is exploratory data analysis. So that's our step 5, exploratory data analysis. So let's go ahead and conduct some exploratory data analysis. Let me see. Exploratory data analysis. So this should be a markdown run. Okay. So for exploratory data analysis, an easy way I go about doing that is using the dot describe method. Using the dot describe method. So calling the dot describe method on your data set is going to give you a quick description of what your data set is all about. So let's say HSP underscore data. If I run this, we'll be getting a quick analysis of our data. So we have handicap column, that's if a patient is an handicap or not. And for age, we can see now that our mean age is 0, maximum age was 115. Tells us the average age value, which is 37. It tells us the median value, which is 37. It also tells us the that about 25% of our data sets are within this age, 18 years, while above 75% of our data sets are within this age value also. So, it just gives you a brief or a data set is all about. So another thing you can do is look at our categorical column. So we want to look at just only the strings or the object column in this data set. I want to call on the dot describe method. Is not okay. It's called D types. Okay. So you can see that for our categorical column, we have gender. It tells us we have 2 unique gender. Female is the top occurring gender, and it tells us it's been frequented about 71,840 times. The most frequent neighborhood is Jadim Kamburi, and we have 81 unique neighborhood. It also tells us our NHS value. We have two unique value. That's if a patient is an NHS patient or not. And it tells us that most patients are not NHS patients. Then we have hypertension. If the patients are hypertensive or not, it tells us that most patients are not hypertensive, most patients are not diabetic, most patients are not alcoholic. Then most patients do not receive an SMS also. It also tells us that most patients did not miss their appointment day. The day which many patients schedule an appointment is on Tuesday, and the appointment day, the day they usually schedule for more, is on Wednesday. So you can see that just using the dot describe method, we've gotten insights about our data sets. We've already known one about this data set. If anybody asks us questions about this data set, we have something to be able to say about this data set, right? So that's the importance of carrying out exploratory data analysis. Another thing you can do is, aside from creating this table, more people will prefer to look at a graph, a visual, a graphical presentation of your data or of this finding. So we can go ahead and create a graph to show us that will show us this analysis. Okay, so I want to do that, and our list is going to be taking gender, our neighborhood, NHS, um, hypertension, diabetes, let's go back, alcoholism, okay, missed appointments. So we have a whole lot of categorical columns, and see what insights we can get from this column. Day. Okay. So now what we want to do is to create a function that is going to loop through these columns and plot us a graph. So let's say the df, we're going to call this our function plot graph. Okay. Okay, let me just make this C. Okay. And we're going to say passing our data set as hsp underscore data graph. Do we want to plot a count plot. So okay, let me go ahead and run this and see what we get. So you can see it's running already, and Now we can call let's copy this. Let's call, okay, I think. See our error from. Mm, Let me just go ahead and copy this so that I can decode where this error is coming from. To this, and I'll be using, let's say, gender. Yeah. Oh, oh, okay, 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 okay. I think I can plots. If I'm using a count plot, then I don't need to add kind again. Okay. So let's see what happens on this. Okay, so it works. So you see, as easy as that. So if I go ahead and click on, you see we're going to be getting, for example, we have our gender, we have our gender, and tells us how many females and males. And with this, it's more easier for you to visualize instead of this table we're having here. Okay, so you can see we have more female in this data set, and of neighborhood, so it's a bit clumsy visualizing this. So let me run this again and we'll be analyzing separately. So you can see it's still loading. Okay. For NHS, we have more patients who are not on the NHS list. Okay. For hypertension, we have more patients who are hyperactive. So you can see the difference, the gap difference between these columns of these different categories. So for scheduled day, we have Tuesday as the day people schedule their appointment. That's the day they make more schedule, followed by Wednesday. Then we have Monday. Okay. Then you can also find out that for the appointment day, which day do they schedule more on? They schedule more on Wednesday and Tuesday. You can see that on Thursday, Saturday, they have little or no patients on Saturdays and Sundays. Okay. So that's one of the important points of carrying out exploratory data analysis on your data set. It gives you an insight on what your data set is about before you start answering the main questions, before you start answering your questions you want to get, the insight you want to get from your data set. You've already gotten an idea on what your data set is all about. So our step 6 now is to get insights and findings from our data, and we'll be answering some of these questions. We've already spent an hour on this already, so I don't know if we're able to answer all questions, but I'll be picking some imports to look at. So the first thing I want to get is to answer questions like to get insight regarding patients who miss their appointments. Want to relate it to the age group, the gender, the appointment weekday, SMS received, and NHS. Which of these patients are more likely to miss their appointment for age group? For gender, male or female, who is more likely to miss appointments? For appointment weekday, who is more likely to miss appointments based on the weekdays? Are there more patients who are going to miss appointments on Wednesday, or more patients who are going to miss appointments on Tuesday? So for trying to do, okay. So for us to do that, the first thing I want to do is to get the data set of patients that are so I want to do that. So let's say each is our health data, and we have the missed appointment. Okay, this is it. Okay, missed appointment, where this is equals to yes. Okay, so we want to return only rows of data for patients who miss their appointments. That's what we want to do, and we want to analyze those data sets. So let me run this. What's this data set save as HSP? Oh god, said heads. So you see, if I go ahead and check this, it's going to be giving me just rows of data. This appointment, they are all yes, okay. So let me save this data set and call this missed appointment data. So this data set is for those who missed their appointment, and we want to analyze this data set, okay. So, so the first question we want to answer is want to understand by their age group, the gender, the appointments, the weekday of patients who miss their appointment. So I'm to copy this and I'll be going down here. Okay. So an easy way we can do this is to, just create a short Python code that can easily do this for us. So for this, I want to look at. So I'm looking at age group. Okay, that's age. We're looking at this column, which is age categorical. Okay. Second column we're looking at is gender. So gender. The next column we're looking at is the appointment day. Okay, so the day the patient made this appointment, which person is more, or which day are people more likely to make appointments that they want to meet up to. So we are also going to be looking at the scheduled day also. I want to see that which day patients more likely to schedule for appointments and they would not meet. And also SMS receive, are people who receive SMS going to miss their appointments, or people who did not receive SMS are the people who are more likely to miss their appointment. So let's find that. So I'll say for I in our columns which we've created, we save that as co. So the first thing we want to do, we want to print I. Sorry about that. We want to print I, and we also want to print okay. To normalize and set this to true. Okay, I want to give it space, so let me go ahead and run this and see what I get. I'm getting an error, and let's see where my error is coming from. data. Why am I always using data? Okay, let me correct that. Which error am I getting again? Sales value counts. Oh, it's supposed to be value counts, not values. Okay. Okay. So we've gotten this, and here you can see we have for adults, we have the percentage of these patients. So we can see for adults, we have 35% of adults who are going to miss their appointment. For middle age, we have 27%, children 24%, and senior we have 13%. So lesser seniors are going to miss their appointment. So we have more adults who are going to miss their appointment. Is categorized as 18 to 44 years. While for gender, where we have female and male, we have more female who are more likely to miss their appointments. For our appointment day, we have for our appointment day, we have Wednesday as the day which more patients are more likely to miss their appointment. The scheduled day, we have also Tuesday as the day more patients are more likely. We can also see that patients who did not receive an SMS are more likely to miss their appointments. Okay. So another thing we might like to do is to put this in a chart, okay, for it to be easily understood. So we can easily another put this in a chart for it to be easily understood. And let me see and just go ahead and code that quickly because our time is fast spent. I was thinking I'll be able to spend an hour on this, but it seems not. So let me just try and do that. So you know the earlier we created a count plot, right? We created this. Okay. So we'll be using this method. Let's copy this. Take this here. Okay. So remember we'll change the okay. So we have missed appointment data and let's see what we'll get if I run this. Okay. So with this now, we've been able to create a chart that shows us of it just tells us. Let me go ahead and click on this so that we can see this fully. It just gives us a graphical representation of what we've done earlier. So instead at this table here, we can just look at the chart and for better understanding. So you can take this for each. Uh, okay, I'm trying to see. Think I'm. No, no, no. Oh, doing something wrong. Okay. Oh, sorry. Cause okay. So let me go ahead and run this. Okay. Okay. So we're in the right place now. Okay. So you can see for child, adults, middle age, now you can see that more adults are more likely to miss their appointments, followed by child, middle age, and least is seniors. Therefore, gender, we have more female missing their appointments. For appointment day, we have more appointments are going to be missed on Tuesday, or appointments made appointment on Tuesday or Wednesday are more likely to miss their appointments. Then appointments that are scheduled for Tuesdays and Wednesdays are more likely to be missed also. Also, people who do not receive an SMS, a reminder, are more likely to miss their appointments as well. Okay, so you can see with just using these 4 lines of code, we're able to, do that. See, create a graphical presentation of 5 columns of data. So you see why Python is very necessary. So we've gotten our insights. Another thing I love doing is after and say, okay, for so day, all these things I'm saying, I like to, add a markdown and, write a brief insight on what I have seen. Okay. So I can say, um, patients who do not get reminder are more likely to miss their appointments. To miss their appointments. So, you can just, go ahead and, um, stuff like that. Okay. So I'm just doing this short. If I was working on a real project, this is going to be much more detailed. Okay. I just want to, open my points, what I'm trying to say. Okay. So for each project, when you are done, give a brief, detailed explanation on the findings you've gotten from your data sets. Remember, you're going to be presenting this to your directors, your executive, or whosoever is employing you to, carry out this analysis. So the next thing we want to talk about is the effect of health conditions on attenders. That's missed appointments and health conditions. So are people who are hypertensive likely to miss their appointment? So it's just same thing, same process we've done. So to make this fast, is okay, because we are trying to answer same questions, but we are trying to analyze a different category. So we are looking at hypertension, diabetes, alcoholism, and handicap. So let's copy this. Hypertension. Are people who are hypertensive more likely to miss their appointments? Are people who are alcoholic more likely to miss their appointments? Are people who are questions? Control V. Alcoholism. Handicap. Okay, so let me go ahead and remove this, and we can go ahead and run this now. So you see, it tells us the different percentages. So for people who are not hypertensive are more likely to miss. Wow. Okay. So you see, 80% of people who are not hypertensive miss their appointments, while 92% of patients who are not diabetic miss their appointment. So you see, just only 7% of patients who are diabetic uh, miss their appointment. So you can see the different insights we are getting from this. So another thing we can do, just like we did previously, we can put this on a chart. Okay, so I can go ahead and copy this and paste this here. This is a column, Control V, and let me run this. So you can see it shows us the visual presentation. Okay, so tells us for hypertension, people missing their, so hypertension, no, is for people who have hypertension. or not. So for these people who do not have hypertension, you can see they make up a larger um aspect of people who are missing their appointments, while those who do have hypertension makes up a smaller percentage of the people who are missing their appointments. So you can see the different analysis we can get from this um data set. So the next question would be answering is, what's the next question here? Is the effect of okay, we've done that. Identifying which age group have higher missed appointment or illness rates. Okay, so this is our next question. Want to see which age group are more likely to miss their appointment. We've done that already. I think we've done that. We said miss appointment and age group. So let's say which age group have more illness rate. Okay, so want to see the different age group and their illnesses associated with those age group. So once the next, now we're going to be using our HSP data once more, because now we're not just looking at misappointments, but want to look at age group and illnesses associated with those age group, right? So let's say age cats. Want to group by okay. And you say we're grouping by the okay. So let me run this and see what we get. Okay. So you can see for child, senior, this is a bit deprecated, so we can't get the full view. So, but you can see for child, um, we do not have so you can see for child, patients who do not have hypertension, diabetics, they are not alcoholic, no handicap. We have a whole lot of them, which is 27,041. And we just have few patients who are handicapped, few patients who are children and are handicapped, and we have 192. So for child also, you can see patients who are diabetic as yes, handicap, no, and we have 42 patients who are children are diabetic. We have yes, and we have who are children and are hypertensive. So for seniors, which are from our ages from 65 to 115 years, we have patients who are they are not alcoholic, they are handicapped, and we do not have any numbers. And so this just gives us a cross tabulation of those findings. Uh, I don't want us to spend a whole lot of time on this. Okay, so I'll probably be going to the next question. If you have any question, please ensure to drop it on our chat box. Okay. So another thing we can do is this last. Okay. So analyze which conditions are common in specific neighborhoods, gender. Okay. So conditions that are common in specific neighborhoods. So I just want to see the top neighborhoods where some certain conditions are common. Okay, so I'll be calling this top five our neighborhood. So let's just say we are grouping by our neighborhood, and we want to look at for the hypertension columns. Want to see which neighborhood is hypertension more prominent. Okay. Ascending equals to first, and want to say dot here to get the first 5 rows. Okay. Oh God, HSP data. Okay. Want to set our values by 9%. Still getting an error. What was it saying? Key error neighborhood. Let me go ahead and see this first. So those values can't I see? Think I want to check if the spelling of the neighbor is we are getting error. NEIGHBOUR. Oh, spelled wrongly. So you could see these the values we have. Our neighborhood, we have hypertension, no, yes, okay. Now I want to go ahead and sort this. I want to sort values, and let me run this. Can go ahead and remove this now. Okay. So would where um patients do not have more potential. We have Jardim Kamburi, Maria Ortiz. These are the neighborhood. I will see patients that do not have hypertension as 7208. So one thing I can do is to make this easy. Okay. I want to filter for those patients that have hypertension and tension. Hypertension when is equals to yes, and want to filter for that data set. So if I copy this and paste this down, first true first, okay? we now want the full data. So let me run this once more. So you can see these are all data and it contains only patients with hypertension, right? Now I'll be using this data set to, get our values, our insights. So instead of using HSP data here, I'll be using patient hypertension and be conducting a values count on this. Okay. So let me run this. So you see the neighborhood where we have more patients with hypertension is Jardim. This Jardim de Penha. Then we have this as the second most neighborhood where we have occurring hypertension, central, and so this is the top five cities or neighborhood where we have more patients with hypertension. So if you want to see that for diabetes, you can be able to get your answers or your insights. So I can go ahead and see this. Okay, so we can change diabetes and we'll be getting those neighborhood where patients have diabetes. So you can see say diabetes. Okay, no. Okay. Okay. So we have to copy this also. Yeah. Paste this here and we'll change this to diabetes. Diabetes and change this to diabetes. Okay, so now let's go ahead and run this and now okay, if we go ahead and run this, you can use the diabetes. Okay, so neighborhood where diabetes is more common, top five neighborhoods that has the most frequent or most occurring occurrence of diabetes. So that's how you can go ahead to questions. Okay, so the last question I want to take is appointment are scheduled and if that affects attendance. Okay. Oh, so any question before I go ahead and you know answer our last question? Any question? Any contribution? Okay. So remember we have these two date columns which are schedule date and appointment date, right? And we okay, and we're able to get their weekday or their day name. So now what I want to do is to get their what I want to do is to subtract the difference between the appointment day and the scheduled day. So let's say for example, I made an appointment yesterday to meet the doctor on Sunday. So tomorrow is my appointment. On Sunday is my appointment day, which is tomorrow, and the day I made my schedule was yesterday. So to get the difference is to subtract on Sunday date, which is tomorrow's date from yesterday's date. So to do that is just easy. With date and time objects, you can carry out subtraction and addition. So that's one of the reasons why you have to convert this column to a date time object. So I can easily subtract our scheduled day from our appointment day and it's going to give us the difference. Okay, so let me go ahead and do that. So appointment day, want to subtract our scheduled day. from our appointment day. Okay. So, okay. So I will just go ahead and call this difference. Okay. So I can go ahead and copy this and paste this here. And I want to see just the first 5 rows. And if I run this now, you see it gives us the day difference between appointment day and schedule day. If I go ahead and say, okay, let me just remove this so that we can see this column. So you can see we have 35 days, 41 days. It tells us the difference between the day an appointment was scheduled and the actual day of the appointment. So we want to see if the longer days of schedule relates to an appointment, to the patient not coming or not meeting up with appointment, or do shorter day difference relate with patient not meeting up the appointment. Okay. So remember we've created a data set where we looked at patients who did not. We can also just go ahead and do that. So let me just say HSP underscore data, and we'll be looking at the missed appointment. Okay, missed appointment. Okay, so we want to just select those rows of data where the missed is yes. Okay, okay, okay. So if I go ahead and, or let me just say dot head to just get the first 5 rows. Now, so you can see we have the difference there: 2 days, 2 days, 3 days, and so forth. So now we'll be comparing that with people or patients who miss their appointment or not. So we've gotten all the rules for just patients that miss their appointment. Okay. So now I want to see okay, so let's say Control V dot group by, want to group by, okay. Okay. Let's say let's see, I can go ahead doing that. I want to see those patients who missed their appointments and the difference in days. I don't know if this works, but let's see. Okay. Okay. Let's run this. Okay. So you can see for the different uh, ascending equals to true, so that we get the top values. The values can't. Okay, sort values. Sorry. Sort values ascending equals to, okay, let's say first. So you could see that patients who actually add shorter period of booking, difference between their appointment and their schedule, they actually tend to miss their appointment. So you could see 0 days, we had a lot of people missing their appointment, 2 days difference, 7 days, and people who had higher amount of time for booking, they had lower chances of them missing their appointment. Okay. So this is almost 2 hours. I would love to bring this to an end here. Any question? Okay. So if we have no question, thank you for tuning in. Ensure to subscribe to this YouTube channel for more data these. And next week we'll try and other projects to analyze more data sets. Ensure to tune in. Okay. So see you in my next video. Thank you for tuning in. Make sure